Okay. So yeah, again, hi everyone. So we will first we'll quickly go through the perspective projection notes, and then followed by that we will go through the new topic. Okay, that's uh, like shape from different cues. How could we find out the 3D information? That's the agenda for today's Zoom meeting. This is the notes that have been written while preparing the lecture, video lecture on perspective modeling. So we started with the pinhole camera model. Okay, this is what we have already figured out earlier, where the pinhole camera model, the object being here, you could mathematically equate it to, suppose if the object from the center of projection is backside by a distance f, you could come up with a model that's mathematically would be same even if you are considering the object at a distance before this center of projection at a distance f. Okay, that's we have worked out, and this is the model that we consider for our all our rest of the discussions. And in addition to that, then what we, so this, then we figured out the relationship between the actual height of the object, apparent height on the screen, and the distance f from the center of projection to the object. So this in fact is the distance here, okay, on the back side where you have the screen, and d is the distance to the object. So if you write that, this h naught will be h factored by a value of f by d. That's what the relationship is. So the last Zoom session, I was outlining how you could do this in a case. So then we were moving to a perspective projection. Okay. So in that case, you have, the goal here is you have a point XYZ in 3D plane, and you are capturing it on a 2D plane. Okay. 3D surface, or yeah, 3D in 3 dimensions. Okay. That's not a plane because, okay, once you are in 3D, and you are trying to capture it on a 2D plane, right? So that point, let's call it as x dash y dash. The objective here is, if I tell you xyz, and if I tell you the distance from the center of projection to the surface, can you tell me what would be the coordinates of it, of the point on a 2D surface? So when the 3D, the whole 3D has been projected, so when you are taking projection of a 3D world on a 2D plane, how does it look like? And given the parameters like where your surface is, what's the point that you are is of interest to you. Okay, so here you would see again in a very similar lines, if you call it as x prime is equal to x times the distance to that plane f by z. Okay, see, notice here at a constant value of yeah, this you are keeping it at a distance z equal to f here, by the way. So that's why here you have f there when you compare with the pinhole camera model. So f by z into x, y prime equal to f by z into y. Okay, so you could have written this expression in similar lines to, so suppose the first naive expression could be x prime y prime equal to f by g times x. So this is how you could write it, as a 2 by 3, right? And what is the issue with this representation that we have discussed? Is there any problem with this kind of representation? Why we were moving to other uniform coordinates there? What's the issue with this matrix representation?
Z is variable.
That's right. Z is variable. So you have a nonlinear matrix. So to deal with that, what you are doing is you, instead of having x prime y prime, you will go to a vector of 3 elements. Okay, u v w, and as a last step, you do the division with this nonlinear varying parameter. Okay. So at the end of all your calculations, you do x prime equal to u by w, y prime equal to v by w. So if you do that, so u v w in that case, you could write it as x y z by f, right? If that is what you want it, and if you write here x y z, so first case you need to get x, so that means 1 0 0. Next element you should get y, second element, so 0 1 0, because here this is x y z, and you need to get z by f here. So here you will have 1 by f. So this is the, and that is giving you this perspective matrix. Okay, I think last time Shashwat was asking we initially started right away with a 4 by 3 representation. Why not use this? This is also an absolutely fine and valid representation, except that now you would see that you consider not all the time perspective, you give some relaxations to the perspective projection, that's called as weak perspective projection. So there, having an additional column here would help you to represent it. Similarly, you have other representations, like for example orthogonal representation. There also this would help you to have sometimes where you have a constant. Okay, this will not facilitate you to have any constant here. Okay, not only that, I think Gautam is mentioning translation. That's also is a very valid point. Suppose if you are moving the screen, suppose in your specs you have given that from a given f you have moved by a given certain value, then what would be the transformation? So to do such things, you would require here additional column. Okay, that's why you would in fact go for 3 by 4 matrix. Okay, and by the way, I could have written the same thing as whole thing multiplied with f. Okay, 0 0 0 f 0 0 0 1. This is also absolutely fine, because at the end, yeah, here if you come back here, I could have, this is exactly same. Even if I write here, for example, fx fy z, that's also is fine, because now if you calculate u, that's equal to fx by z, right? Because the whole thing getting multiplied by a same constant would give you still the same result. So hope this notation don't get confused if you somewhere see fx fy z there, and that's equivalently given as this matrix. Hope everybody is able to follow that. You are just, you could multiply the whole matrix by f, still it would, in fact you could multiply with any constant. Reason being, at the end you will take a ratio of the first element to the third element, the second element to the third element. Always you are taking ratio of two elements. So if you uniformly multiply the whole matrix with the same value, it doesn't matter, it gets eliminated during that during the division anyway. Okay, so the next one was, as we were pointing out, instead of having simple xyz, you put one more here, 4 by 1. So that would introduce here for the time being a 0 column. Okay, that you could see later that would change. So if nothing is mentioned, and if you are asked to write the perspective projection matrix, this is what you could go for. So this 3 by 4 matrix, where you have the last column zeros, right? So that's the first thing we did it. And then in the class, we were Zoom session, we were discussing that the parallel, we all know that parallel lines could converge when you are doing a perspective projection. And the point we mentioned there is, suppose you have multiple parallel lines that are going to converge, they would all in fact converge to the same point. And this point where they are all converging is referred to as vanishing point. Okay, because that's where they are vanishing from there. Parallel lines are completely the lines are becoming one, and thereby you could say that they are vanishing. Okay, so the goal here is to that intuitively it makes sense for us that these all lines would converge, but how could we say mathematically also, how could we say that these all points would converge to the same point, was the idea of this discussion that we had here. Okay, so there what we were doing is, see, just like a slope and an intercept. So suppose if you have in 2D, all the lines that are having the same slope would be parallel, right, irrespective of where that is. And then it's just enough if you say the intercept or one point on it, you could say. In similar lines, parallel lines in 3D world, is what you need to say is what is its A, B, C value. So that matrix, whichever you have, so anything that that grows in this direction from different points will all be parallel. So for example, then if I give you x naught, y naught, z naught point, okay, so this point, now you have this vector here, okay, a, b, c, need not necessarily be a unit vector, and then you add it up with it. So that would either grow in this direction, this point, or in this direction, which is parallel to it. Now you take another line with some other point, and then you just keep, so this is where you are adding this vector again. So again, it would grow either in this direction, or in this direction, right? So that is how you could characterize set of parallel lines. So each different parallel line will have a different value of x0, y0, z0, or then you call it as x1, y1, z1, x2, y2, z2. But all of them will have the same vector of a, b, c. A, B, C, each one is telling you respectively in x, y, z directions how it is, at what proportion it is varying. T is something you are using common across everything because you are either increasing or decreasing things. So that's essentially equivalent to scaling this vector, right? Again, if this I discussed it in more detail about this representation in the video lecture, so you go back to it if this is not obvious at this point of time to you. And then you vary t from minus infinity to plus infinity to get the lines. So what's the objective now here? Okay, we were able to represent a set of parallel lines. We want to see what would be the result of their perspective projection. That's the goal here, right? So how do you see that? Perspective projection is nothing but x prime of t is equal to f by z into x. So you substitute those things here. Y prime of t equal to y by f by z into y. So you know now x, y, z, you substitute them here. These are the expressions you would get. So as x increases in one of the directions, that means the parallel lines as they are moving either forward or backward. Okay, so that's equivalent to if you look at here, t taking it minus infinity or t taking it plus infinity, you would like to see their behavior. So that's what you are substituting here. What would happen to 1 minute? Yeah, what would happen to these values of x prime and y prime when this t is varying from minus infinity to plus infinity? So that case, you could see this is so large. This is now x naught, z naught can be neglected. Similarly, y naught and z naught can be neglected. So where do they get projected in the image? So this is projected at a by c times f and b by c times f. So this is what you would be getting here. And you could already notice here, now this is becoming independent of where your x0, y0, z0 are, correct? So that means you could say that all of them, irrespective of where these parallel lines have started, they would eventually in a perspective projection would all be converging to a single point, which is independent of the starting points. So that's the proof of this, okay? And then we had also seen now, what if your c equal to 0? Okay, here if you take the c equal to 0, that what does that mean? Your lines are parallel, but that c equal to, but your z value is constant for all those lines. Okay, so that's you could think of having a camera on top of your line. So they would be there. This is an exception where you will have all lines remain as parallel there. Okay, that you could see here. They all see again x dash y dash. This I think in the recorded notes I was saying this doesn't exist. That was a in the flow that was a mistake. It only tells that x prime of t and y prime of t would depend on your starting points. Okay, they all will not converge to the same point. Okay, so that's what you could get here. And then the other one is orthographic projection. Okay, so far clear? Before I move on to from perspective projection to orthographic projection, any questions so far?
Sir, that point of the vanishing point.
Yes.
Sir, like what coordinates determine the vanishing point? I got a bit confused in the notation there.
What they determines is your A, B, C values would determine. If you look at it, you see the slope of those points in a way.
Yes, sir. Actually, so x comma y is the point where they actually kind of converge, right?
No. These are the points. This is just one point on your parallel line. There are set of parallel lines, right?
Yes, sir.
So how do you define a line here in 3D? That's the question. So had it been a 2D, you could have something like y equal to mx plus c, right? 2 points. So then if you are given the slope and an intercept, you could represent that. Now if you change this c1, c2, they are all the lines that are having the same slope that are parallel, but they are different lines. Is it not?
Yes, sir.
Similarly, if you look at in 3D, what you could say is this ABC is what is common for all these lines. And
Yes, sir.
on one of the point, if I give you now, it would give you different lines. So this is all this is telling you is how are the points on this line, or how is this parallel line going to, what's going to happen to that parallel line? That's all it is telling you.
Okay, sir.
Okay, and suppose when I am increasing t, what does that mean on this parallel line that has this x naught, y naught, z naught? I am looking at the either this extreme point or that extreme point on this line. That's what I am looking at.
Yeah, yes, sir.
Is that clear?
Yes, sir. That point is clear.
Yeah, good. Was this your question or it was different?
Question was actually different. Like this is actually the interpretation of 3D lines. How we analyze 3D lines in actual. Yeah. So like if I want to, how does this converge into this the vanishing point?
Okay. See, that's what we are looking at. What we are looking at is, see, as long as this x naught, y naught, z naught are different, they are in fact different parallel lines. So far clear?
Yes, sir.
Okay. Now what we are seeing is how can we move across each of those lines now? See, at t equal to 0, I am at x naught, y naught, z naught, right?
Yes, sir.
So how could I move across that line to one of the extremes? So I want to, is my question clear? I want to move on the given line, x naught, y naught, z naught is given. Now I know the line. Okay. Now the question is, I want to move to the extremes of that line. How can I move that to the extremes of that line?
Vary the value of t.
Correct.
So
So I would say that as t tends to either minus infinity or plus infinity, right? I will move to the extremes of that line.
yes, sir.
Correct. So now what I am doing is, as I am moving to the extremes of each line, what is happening is what I am looking at here.
Okay, sir. Okay, got it.
And then what I could see here is this is in fact is independent of x naught, y naught, and z naught. That means which is that parallel line we can't anymore distinguish. All of them are converging to the same point.
Okay, sir. Got it.
That's answering your actual question you wanted to ask, right?
Yes, sir.
Yeah, good. That's good. Yeah. Any other question?
No, sir.
Okay. So then the orthographic projection is you have just x prime equal to x and y prime equal to y. This you could think of as if all lines are coming parallel to your center of projection. Okay, this is something you could think of it in that manner. So that means if you write it in terms of UVW again, you could write it as x by 1 itself, because x by 1, y by 1, because your x prime equal to x, y prime equal to y. Okay, so this is your representation. And then if you want to write it as again a matrix representation, to have all with a similar matrix type representations of 3 by 4 or 3 by 3, you could see here you indeed require 3 by 4, because this here you want 1. So anything multiplied, if you just take xyz, okay, not good enough. You need a constant there. So what you would do is you introduce 1 and you introduce in fact this also would come here, and that's giving you the orthographic matrix. Okay. And then the last one is this is the common approximation that you would be doing for simplifying your modeling sometimes, is that you would assume that the
Sir,
object. Yeah, yes sir.
sir, I have one doubt.
Yes.
Like at t equal to plus and minus infinity, at both points the points are converging, right? So we should have 2 points of convergence then in the 2D image.
Yeah, anyone have an answer for that question? That's a good question. Any attempts from other students for this? his point is
What
that
was the question again?
the question is that it should then have two vanishing points, not a single vanishing point, because you are varying both the plus and minus in plus infinity as well as minus infinity. This is going to happen. That's the question.
If the parallel lines are on both sides of the, from where we are seeing, maybe we'll have to.
Yeah, unfortunately. So imagine it this way. We are also making a 2D projection of lines, right? For us, when you are looking at, see, you are standing on one side of your, say, assume that the parallel lines are going on both ends, and it depends on which direction you are looking at. See, you might be standing in the middle of those parallel lines. You look at in one direction, in that direction that goes to infinity. Now you make a flip of yourself by 180 degrees and look at it in the other direction. Then in that direction it goes to 180 degrees. But in your single image, you cannot capture both minus infinity and plus infinity ends. Your center of projection and your object from where you are looking at is only one side. But if you had it's not, doesn't mean that you will get only that. But if you had just like turn back 180 degrees and see it, you will see the other direction converging point. Does this make sense?
Okay, sir. Yes, sir.
Yeah. So this is exactly what we could see. We all do perspective projection, right? Our eyes do. Our eyes and brain interprets it through the perspective projection. You could see on both sides converging, but at a given time, where the object is, where the center of projection is, where your sensor at which this has been falling on, that depends on whether it is at t equal to plus infinity or t equal to minus. You cannot have both in the same thing. You cannot go in both x and y and then have, there is no way you could have the sensor in covering on both sides, right? Hope that is clear.
Yes, sir.
Okay, good. Right. So when it comes to the weak projection, weak perspective projection, what you do is from your center of projection, your object is so far, okay, the distance is so long or so far that within this object you might be having some changes in the height, but compared to this, these variations can be neglected. Okay, that means your object of interest has a constant value of z is what you assume there, right? So in that case, what would happen is you have this z naught is constant here. Okay, f by z naught into x, f by z naught into y. So both x and y are scaling by same value, and this is happening across the entire object. So x prime equal to sx and y prime equal to sy. Okay, so that means now instead of having here for z, you could, this constant, this variable would now, when you compare it to perspective projection, would move here. So that's what you get it for weak perspective projection. So these are the three things that we have discussed. Hope that is clear. If that part is clear, let me I'll move on to the next topic. Okay, interpreting the 3D from 2D. So any questions before I move on? I assume then there are no questions. Your silence is, I take it as your saying no, there are no questions. Okay, fine. So I thought rather than a video recording thing, I thought this introduction would be better if we just interactively discuss it. So that's why I haven't made the video for it. We will discuss it now. Okay, let me again share the screen. And let me turn off again my video. Okay, so by the way, have you heard this expression calling shape from X? That's how they name it. Shape here is, by that they mean the 3D shape. and from X means that's the variable. Okay, you could submit different things. It's a very hot topic, particularly in 1980s. That's where this has in the computer vision, this has drawn a lot of attention. Okay, then this is a very common keyword or a buzzword during those days, but still, but even today, this is still a hot area, and lot of research is going on. And in fact, a lot of research has been already done as well in this area. Okay, again, I took few from, particularly for stereo, I took from Aaron Bobbick's lectures, and few other, I don't exactly remember the sources. I in fact took from multiple sources, the other things I compiled from multiple sources. Okay. Before going to how you interpret from multiple images, I think sometimes in between, occasionally we were talking about two eyes are helping us to interpret 3D information, but that we will come a little later. What we would first do is, can we interpret to an extent 3D from a single eye? What do you think? In other words, interpreting 3D, you could think of it as interpreting the depth or height, whatever we call it usually, depth. Okay, can we interpret depth from a single image is the question.
No, sir.
No. Are you sure?
Unless we have some other structured light with us.
At least see, I'm not saying maybe very quantitatively, but qualitatively. Do you think we can make some qualitative assessment of how? See, we might not say how much exactly it is there, 2 meter and then 10 centimeters kind of quantitative thing I might not give, but can I not with just a single eye, if I am looking at, okay, that's equivalent to taking one snapshot. And then with just one eye, if I have one eye alone, okay, or let me not say that I have one eye, but let me say if I am looking from only through one eye, okay. So are we not capable of making an assessment of the depth qualitatively at least?
Yes, sir, we are.
How are we making it?
So because of like we know of the depth because it's already in our mind or somewhere. Just because of a priori knowledge.
Yeah. So let me put the question slightly differently. What are the different cues? Okay, you know the word cues, right? Are kind of hints that we use for interpreting the depth information from just a given image. See, if this is not the case, if we are not able to make an intuitive interpretation of depth from 2D images, we won't be watching any movies at all, or not just movies, anything that you are seeing on your screen, for example, is at the end of the day 2D, right? All so be it your movie screens, or be it your computer screens, or be it a painting or whatever it is, unless we have been making this has become so intuitive and for us right now that we almost unknowingly interpret 3D, is it not? So the question is, yeah.
Sir, what I think is like if some size of an object is smaller, we interpret that it might be farther away, and if it is larger, it might be closer.
Yeah, one cue is size. Any other? There are so many other things also. We unknowingly put together a lot of different things coming from different cues. One is the size. So that is where you have a rough idea of how much is the size of the object, or the relative sizes of the object within the image could help you. Any other cues that we use for interpreting 3D?
Lights and shadows.
Very good. So the shadow tell you, and also the lighting. So shadow is, for example, shadow tell you, yeah, where the object is, that gives us rough intuition. And then objects which are closer to us, you could expect that to have more light or less light under uniform light conditions.
Focusing will also help us, like if it is
sorry.
Focusing will also help us, like
yeah, good. So focusing is another thing. How do you make use of focusing to say whether the object is close or far?
like an
Yeah, it's not exactly the focusing.
Little idea we can get.
Yeah, so it's partly correct. You are into, yeah, I think you have the same feeling. But the idea is that the textural variations are finer variations you could see well, where in those regions which are closer in that given image, right? That's what I think you wanted to say.
Yes, sir. Like.
Yeah. Yeah, that is correct. So you mentioned about the size, you mentioned about lighting, you mentioned about shadows, you mentioned about the textural variations in the object closer versus farther, or the finer variations. Okay. Any other thing we make use of to interpret whether objects are close or away within a given image that has objects in from the 3D world captured? Okay, I think you mentioned some. Let's see that.
The perspective can be one.
Very good. That's right. See, the moment you see this railway tracks, without it means before you say anything, it's already interpreted in your brain that it is the points are. 1 minute. Let me make sure this pen is on. Okay. So this region is far, and this is where you are closer, and this guy is standing somewhere. Okay, here and looking at things in this direction, right? So it is the perspective projection that's there in your brain, because we got used to looking at all these things, and now in a split of a second you do based on perspective projection, right? That's one thing we use it inherently. Then as you were saying, the size of the objects tells us something. So here you could see, you make a, you see, unless somebody is cheating you purposefully while making this picture, okay, you immediately feel that this object is of same size as this, but somewhere this camera, this image has been taken closer to this object, and this is farther, right? And then the other point I think Ketan was mentioning is this looks texturally, you could see things very clearly here. This is going farther, so you won't see it, so that is there. And then you inherently make it, these are all we are trying to put it into, constructing into sentences and expressing it, but this all will happen. This is again, you could see some perspective projection in this corridor. So we got used to seeing corridors, of course, which are parallel, okay, on both sides. Very rarely you train your brain to do that in a different way. So that also will tell you that this is going in this direction, and in fact this is parallel. These things are closer to you, right? The size would help you, texture is helping you, objects are helping you. And then what about this? Not only that, to tell that this is farther or this is farther, okay, this, let me call this A and B. I'm sure nobody would say that B comes before A, but how are we telling that? Intuitively, or without even paying any attention at all, almost. Whether A is closer to us or B is closer to us.
Yeah. A looks closer.
Right, of course. I'm sure no, this question is asked, nobody would get failed. Okay, so this, because they appear higher up in an image. So if you look at an image which are farther here, so you look at this image in this 2D image, okay, this is what I call it as higher in this direction. If you are looking, that which are farther would appear somewhere here, is it not? So that tells us these are all interpretations almost without any like special attention, we are able to do that. And another one is one of you was telling about the lights and shadows. Okay, this is what in painting to look it nicely. Again, they all those all of you who are the artistic people drawing these things would know it inherently almost. Okay, will accordingly, where for example where there is lot of shadows you could expect here with so much of its hair there, so you would draw it, the shadows there, and different lighting conditions also. That part which is coming closer to you, you would putting it light and other things. Okay, this almost done by nature naturally. So I think this is one thing that you guys have missed to inform. Another way you do it is, suppose this person A, let me call it as person A, B and C. Okay, is person A is closer to the camera or B is closer to the camera? One is, as you mentioned, you could say it is up in the image, but again he might be sitting and yeah, again whatever explanation to give, counter explanation will be difficult. But you could see here this person is occluded here, that you could clearly see. For example, this person's hand is occluding this person's hand. Okay, this occlusion also in here we make use of this information. Like for example, here you could say that this pillar is before this table because this pillar is occluding this, right? All these interpretations you would do. So this is another thing you would use as a cue for figuring out whether the which object is closer or relative depths of the things. The closest objects appear in front of those farther away. So this is coming front, and also that is in a way occluding the other. So that's another cue that we all use. Okay, and this is, you could see the texture here very clearly here. Okay, this, as you are moving on here, although there are a lot of things there, this is a kind of blurred kind of distance. Okay, the texture gradient is not very clear, so you could say that this is closer than that. We are already calling it as background. Okay, and this is something you all would have felt it. Okay, maybe not many of us would have explicitly reasoned it and figured it out why, particularly being in the having our institute in the background, the hills as our background. On a very sunny day, you feel like the mountains are closer to you, and on a hazy day you feel like the mountains are far. Have you not felt it? So on some fine sunny day you feel that the mountains are, you are very close to the mountains. The same thing on a day where there is a lot of cloudy weather is there, or a lot of hazy or pollution, because of that whatever it is not clearly visible, you feel like it is far. No, none of you have felt that? On some fine sunny day you felt that you are indeed very close than what you were thinking earlier. This is because again we interpret things, because the haziness is something where we interpret in, there is no way there actually you are able to interpret how far it is, but it's because relatively how it is looking like in different scenarios, your earlier captured image versus this, that would tell you whether it is close or far. So the haze also have an impact. Okay. And then suppose you are watching a movie where a car is going on here. Okay, and then the other different things are moving here. Then there is whether the, so we have also seen it in optical flow, that example of the table moving and on that having a checkerboard or whatever it is, the objects closer to you would move faster, right? That's how we also make use of the motion, relative motion of the objects, to figure out whether that object is closer to you or far away to you, right? So this is another cue that we all use. Okay, and then let me put a question to you. Just like we have eyes which have come without any of the effort, do you think that in interpreting 3D from 2D images using all these cues is natural to us or innate to us, or is it something that we have learned over time? What do you think? Do you think that this
Learned
has
over time.
Okay, none of you thinks that this has come
Learned over time.
this has already an installed software. Okay, by the time you have come, this is in your DNA. None of you think so?
So from the beginning itself, we were provided with stereo vision. So
no, I'm just talking about stereo vision is there. That I am not contradicting. what we are focusing right now is just a single image is there, not the stereo vision of two eyes. Now, see, interpreting these images, you might be having stereo, but the stereo is useless the moment you are looking at a 2D image, right? If you are looking, all of you are looking on your computer screens, your, in fact, your 3D, all of our 3D stereo vision is useless because the information itself is 2D. Is it not?
Yes, sir.
Because both of your eyes are not looking at two different things. Both of the eyes have the same input. So, and that's again on a 2D screen. So that's useless. So all we are now discussing is, for example, this 2D also, as we mentioned, using all the cues we mentioned based on the textural differences, based on the perspective projection, based on the lights and shading. Okay, all other things, we are able to interpret that this is 3D, or the relative locations of the objects we are able to interpret even from a single 2D image, right? So the question is it a pre-installed software that comes with your hardware, okay, or is it something that we keep learning over time?
You learned since your childhood like that.
That's right. That's right. It has become so natural by the time that we have learned it. We have already realized that we have learned it. We already learned it. It's something like that. So before we know that we have within us the lungs, okay, the heart and all, the heart is already there and it's functioning. In the similar lines, you have it. And this is a very interesting experiment people have done. Some guy called Turnbull, he has studied, these are some Paijamis they call, some group of tribal people in the, they live in a very deep Amazon forest. Okay, the forests were so dense, you could even hardly see anything more than few meters around you, and they are in such a deep inside the forest. They have never seen anything called as an open space where you could see mountains, okay, you could see far away things. They could see only few meters space around them. That's how they have gone there, they have brought up there, they never moved away. So it is on them these experiments have been done, very interesting experiments. Okay, they were for the first time in their life, they were taken outside this Amazon forest, and they have been shown the forest. They could not, so the moment we see it, we could say that this is a hill, right? They have no clue whether they have seen whether it is a hill or a cloud. They have no clue about it. It was for the first time they were looking at such things. And then this buffalo, they have been seeing it in the same Amazon forest. They have been looking at this buffalo, but for the first time they have seen this buffalo from long, and they declined to accept, or they declined to agree that this is a buffalo. When they looked at it from far, they said that this is an insect. Okay, no way this could be a buffalo, because that cannot be so small. We have never seen it so small. That's their interpretation of it. And similarly, it is for the first time, means even the elder people there, okay, when they have been brought up, they cannot believe that the boat could be so small. This is for the first time they have seen it from so long shot, and they refuse to believe that it was a boat and it's holding two people there inside it. Such a small thing cannot hold it, so they refuse to do that. Okay, so this is very interesting thing. So we acquired it without really knowing or making a conscious effort to acquire this. So these are all, this is a very interesting examples that tell us that this is not something we have it inherently, but this is something we look at the objects as a child. We look at the objects, okay, we have this perspective thing, and then over the period of time we gradually acquire this skill, you could call it. So just like this perspective projection, you keep looking at it, they look, so then you make this realization that these objects are closer and the other objects are far away. Okay, so this is a very interesting study that tells us that this is not inherent to us, but this is something we acquire over time. Okay. So this again, this is again, by the moment you see it, you could tell that these are all parallel house perhaps of the same size, but you are taken from somewhere here, you have captured that, and that's how it looks like. So this perspective projection is something. Okay, so any questions or comments so far on this? This being an acquired faculty than being an inherent faculty. Okay, I think all are in agreement that this is an acquired faculty. That's good. Okay. So yeah, this is again see what all these computer vision algorithms attempt at is that whichever we are doing intuitively, can you make an algorithm do it? Okay, that's the thing that these algorithms attempt at. Okay, say for example, the moment you look at this face, okay, this being here dark and all, you would say that that's far away, that's in the background. Okay, this part being very well lighted, you assume that this is closer to you. So simply if you draw, for example, that this is just simply the intensity profile. Okay, the intensity profile, if you draw it, of course x and y, then the surface has been plotted. If you look at it, that intensity profile is in fact giving you a reasonable estimate of the relative distributions of the depth of the face, which is very interesting. So this is called as, in that substitute x equal to shading here. Okay, and then of course here we are making a lot of assumptions and lot of ideal conditions here. For example, you could come up with a lighting or a makeup which would give you the feel otherwise. Okay, this is something when the people experts in makeup would purposefully or consciously exploit. Okay, the face which is very thin, the makeup to the cheeks could be given in such a way that for us, when we are looking on a image of that, the 3D acquired in 2D could give you a completely different interpretation where you feel the face features differently. That's quite possible. Just that you need to play with the lighting and the reflectivity, because that's which is getting reflected is captured by the camera. Okay, you play with those lighting conditions, the reflectivity, okay, the makeup which is used, resulting in that reflectivity to appear the face in a different way. So that's basically shape from shading. Okay, this is again just we are giving one sample of this, but again there are a lot of works. This is shape from shading has been a very interesting problem people have worked out. This is again another thing people, this is even not, I think this work is not very old as such, I guess. Okay, I don't although remember right now. Is, for example, you look at the strawberry in a, yeah, this image is perhaps small, but you would see a pattern. There are objects where you could see a pattern. If the pattern is continuously there, you could look at the size of that pattern as well as the orientation, how the pattern is varying, and that you could in fact represent the 3D of that based on the textural changes. So the size, okay, the orientation of the textures, okay, that would keep on changing here on a strawberry. Okay, for example, that's a very nice example there. And again, assume that a building has been constructed here which is having a uniform texture throughout, and the moment it is appearing to take some turn there, what you could see is the textural unit that you are considering here as with which you could observe throughout would take a change in the orientation as well as the size of it. So based on that, one could interpret the 3D. So that's shape from texture. Again, a vast area in itself. A lot of people are still doing it. This is again to enable your computer vision algorithms with all the cues that we are interpreting almost spontaneously because of the learning that has gone through in our brains. Okay. This is, I think, again, one of you had mentioned that is the blurriness that you would see. See, the moment you are looking at a camera, you remember you are taking a picture of it. So the depth of focus is different, right? For an object which is in depth of focus before and after that, that becomes blurred. So this is something you could one could exploit here the same way we do it. Okay, and again there is a whole lot of literature on how do you automatically find out whether a given region is in focus or out of focus. You could, for example, look at the distribution of intensities. Is a very simple thing to do, but there are more advanced ways of looking at it, and from that interpreting how the 3D information of it, out of it. Okay, so then another information here is you could in fact if the object is moving, okay, tracking of that object and assume that that object is moving at a uniform with a uniform. Yeah, I think Yashwant has raised his hand. Yes, yes, Yashwant, you had a question. Okay, maybe he has raised his hand there by mistake. Okay, while it is moving, depending, its speed is essentially dependent on how close or how far it is. Okay, when you look at the speed of other objects there. So still notice here, you are still looking on a plane, okay, or you are looking with a single eye. If you want it that way, that's also is fine. You don't have that 2D disparity coming from two images, but here it's not two images but images over time that would tell you something about the object heights. Okay, these are all as I said very popular topics of research. Still again, they still remain to be very high topics of high importance. They are referred to as shape from X. Okay, shading, texture, motion, focus, and all those things. Okay, so yeah, as you all know, we and many of the animals as well are equipped with couple of cameras, okay, calibrated and acquiring slightly different images. And now depending on whether a given point is closer or far away, the disparity that you would see for that particular point in these two cameras or eyes would be different. From that, you would be able to in fact interpret whether that object is close or far. Okay, that's what you would be doing. So this is a earlier shape from motion we have seen it. So there is another area actually, shape from multiple views. Actually, this is another topic where they would not necessarily just two images, they take multiple images and from that make an interpretation. Again, this could go again, this has something to do with key points also. That's one way of people doing that, to find out the correspondences. And of course there are many other ways things have been interpreted as well, and thereby giving you the interpretations. So this you could think of this, we call it as a stereo vision. This you could consider it as a special case of multi-view geometry. Okay, and now the whole for like the perspective now we would look at is why multiple images, why not a single image. Okay, so from here, from the first image, why would you say why we need multiple images, or from both images? We all do it, right? Maybe in different instances. So it's like you once you do not have the depth information here, that's what you would like to get it. This is something like this. This is where the camera, or where we are getting a projection. You could see here, this is, if this is optical center, whatever got projected here could be coming from any of these points, right, which are there on the optical center line passing through that pixel. So to resolve from where we have been looking at, if you have two different so for example from a slightly different viewpoint, you could also see, then that would be useful for interpreting from where it has exactly come from. Okay, so people used to this is again, you will be surprised to see, this is something from 1838 invented by Sir Charles Wheatstone. Okay, I don't know whether this is same as that Wheatstone bridge and all, that I have no clue. That anyway, that name is so common, so might not be the case. You could see here, this is again my guesswork. There is one image to be seen here, For you, one eye will be here. Okay, you will be seeing from one eye here. Another eye would be on this side. You'll be looking at. So these two are shown two different images in the similar way as our eye looks at. So these were all very popular toys that people have generated not only in 1830s but beginning of even 1900, 1860s and 1900s are also. This is a very some chart. Oh, right. So people used to use it. So this is again, it is very fascinating, and yeah, we take it for granted and we don't maybe recognize it so much. But at that time, looking at just from 2D images, feeling 3D was a very fascinating stuff. So they used to project here an image or show an image which you would have been seeing had it been with a single eye. You are looking what you get there, and the other image, possible image with a shift there is projected from here, and that would eventually give you a 3D thing. Okay, this is maybe 1860s or something like that. Okay, Abraham Lincoln's 3D has been done. People were fascinated with it. Again, a very similar setup. They take the pictures as if you are looking from two eyes, whatever disparities you expect from the pixels, and they give it to as inputs independently to two eyes. So with now two images, you are able to get the feel of 3D. Okay. Then this is again, you all know this guy, right? Who is that?
Thomas Alva Edison.
Right, Thomas Alva Edison. So this again, you see blue and red. Okay. So yeah, with this, by the way, with whatever background that we have discussed so far, can you tell me now, you all have seen 3D movies, right? I'm sure no one will be there who haven't watched 3D movie. So how does the 3D movie work? How will you be able to perceive a 3D? So what did they give it to you the moment when you want to?
Polaroid specs.
Oh, no, that is too technical. Can you bring it down?
3D specs.
Yeah, you are looking. See, by the way, you are looking 3D from that. What does it have? Can you make one?
Blue and red films.
Can you make such 3D specs?
Blue and red films.
What all does it have? What is all required for making those specs?
So actually, the 3D specs, the two different eyes have two different Polaroids. So one captures only one image, other captures the second.
Okay. Can you do it yourself idea for that? Can you tell me something? So you want to make it yourself. So any simple polarization can you suggest? In this Corona time, you want to do it at home, for example? Yeah, maybe I'm not sure how far it is possible, but just, yeah. Can you tell me something, any simple way to polarize light? Let me put this question in this way. Is there any simple way you could polarize the light that has been received, or the image that have been received by individually by each eye?
Using color filters.
That's all. So you take two color papers, one is blue and another is red. Okay, and there should be a slight distortion, or slight means whatever is required for each eye, so that which you see with two eyes, okay, those 2D images should have that. And suppose if you have a blue color, one blue color like paper, you have not paper, that whatever you call it, so that should be transparent one. What do you call that? Yeah, transparent sheet of blue color, okay, which you could see through it. Okay, something like a lamination paper which is in blue color. Okay, we all means yeah, earlier people used to wear in all gatherings and all. Okay, kids used to buy them, right? So the blue color thing sheet, if you keep, okay, what is it that polarizes? Can you tell me in bit more detail? What is it that it filters out, and what it makes you to reach to the eye? Suppose I give you a red color transparent sheet of blue color. Okay, is it a what does it do essentially? or what it doesn't make you to see if you have a blue color, or what is it that it makes you to see?
It makes us see the red color part.
Right. That's anything other than blue, it makes you to see. So if there is only blue and red, what you said is correct. So because that blue color, if there is something that merges with this blue color and filters out, gets filtered out, you can hardly see anything there, right? So when you are looking at a 3D movie with these filters, all it you could think of it is you just yeah, I'm sure you all while watching a 3D movie would have removed your that filter and have seen it. All you would see is still you could manage to see it, but with some blurring effect, is it not? Just like the first image there in the slide. Might not be so red and blue, but essentially that's what would happen there. You filter out and give as an input to each eye a slightly an image with a disparity that would calibrate for 3D information. So that's all that is required. So yeah, these were in 1923s. Again, you could look at the timings here. Okay, this was a public library, stereoscopic library. Okay, very popular those days. Of course, now you have them in home TVs itself. So this is not so fascinating these days as you have it at home itself. But that time, for example, when people went to the moon, they have captured the stereoscopic images. By the time already this is there, and then since people cannot go there, people used to see those things used to be made and kept in the libraries. People used to go there and how it feels like looking the moon in 3D. So that's something people used to see it. Okay, this is again that time itself. These are also made long time back. Okay, I'm not sure if one of you could try if you use blue and red color like this. Okay, if you have something, might be if you look at it, you could also get a feel for that 3D feel here. Okay, provided it did not get disturbed in copy pasting and it didn't get changed its intensities much. Okay, should not be. Okay, so this is again the Darjeeling Bridge. Also happy to see in others presentation something from India. Okay, this suspension bridge from Darjeeling also people used to see in 3D. That's one thing. Okay, this Mark Twain, the same museum also, UCR Museum of Photography, has these pictures of Mark Twain. Okay, playing okay, the spool table. Okay, so billboards. What is it? Yeah. Okay, so that giving you in, so you could see here this being, yeah, this is again guesswork. So there is a large movement here that gives you that this is a closer one, and that depth, sense of depth is what you would be getting there. Okay, so yeah, so far what we have seen is the depth information would give you so the disparity that you would see between the two images between the two eyes would give you a sense of the depth. Okay, and in the next class we would discuss about we will go to the stereo vision topic, and that's what we would be analyzing. Yeah, maybe I'll see if I could make a video recording for that. I'll do it, and then that we will discuss along with a few other topics on that. Okay, so is that clear? This again is a very introductory thing without any math for the first introductory one. Yes, Abhijit, I think you're asking something. Yeah, Mohammed, yes. Okay, that's a thumbs up. Okay. Any questions? And what about the presentations that have been done so far? Yeah, I got 30 people have done it. So 25 have submitted, which is good. Okay, 5 haven't submitted. One may not be submitting. So please, the person who might not submit, just let me know, and let me know the reason as well. And then what about the rest? So let me anyway stop this recording here. This is enough for the recording part. I'll stop here the recording part. But anyway, for a few more minutes, we'll continue this meeting just to get any clarifications.